Test it now. Is that better? Okay, wait, so you guys should be able to hear that, and now that thing can see that. Okay. That's weird. Yeah, that's, I apologize, guys. That's, I don't know why it is, but when I grab my Yeti microphone here, the button's right here, and I've never hit it until the last few days. So maybe that, okay, that looks like that's better. I'm getting audio over here, but my desktop audio is still not coming through. So hold on a second, because that should be at least, you guys should be at least able to hear. Maybe you guys don't care about the music that much, but okay. Is that better? Should be a lot better. Sorry about that, guys. I got a message. It actually was a message from one of the guys in Discord that told me, yeah, I don't know what was going on. Sorry about that. All right, so let's start over. So what I'm doing here is in the home lab, I have one. I was mentioning earlier that, you know, Ranger doesn't, I don't think Ranger's got a long time with us left, man. He's getting really old, and a lot of my friends that have dogs and have had older dogs have been saying how near the end they just kind of drop off quick, and it's like, well, I mean, Ranger's been dropping off pretty bad the last couple months, so we're hoping he can hold through. But we had a big party on Saturday, and he was really anxious, and we're having another party this Saturday for my wife's younger sister, so we're a little worried that he's not gonna, we're gonna keep his bed in the same place, we're gonna not move anything around for him, but he just, it's like he wants to be social, and he's, you know, very nice, very kind dog, but he just, like, I think he wants to be, like, he just can't calm down when people are around, so. All right, yeah, thanks for that, guys. Sorry about that. I didn't even realize I had no audio. That was something to do with probably the update when the system went down. So yesterday, one, I had my internet go down, so I was hopped over on my other internet, and then two, my system rebooted last night, so. Wonderful, right? It's always wonderful when audio changes and shit. So anyways, where I was going with that is I needed to check my systems because I have all these systems here called Hammer. And I do have a Hammer 25, okay. But apparently I left that off the list here. But you really don't need, I don't think for this, for the course and for how many people we've had, I don't think we need that many. So we're going to go ahead and change this down to like Hammer 10. We've had a lot less people do the security course. Now I'll move this to maybe like just 11 to exit. And what I'm going to do is I'm going to come down here and I'm going to say DD. Just hold D. All the way down to right there. All right, so now they can go through Hammer 10 and then that. And what that will allow us to do, if we have done that, which we've done that the way we want now, is if anybody comes in through the MC Hammer connections from now on, they're only going to see the first 10 nodes. And that's fine. That works for us. That's enough capacity. I have another plan for how this script is going to work, and I need to run it through with some of the guys and check out some of the bash and stuff. But we'll do it much more efficiently, and then we'll just say pick if you're going to Hammer or if you're going to the normal nodes for the sysadmin or the security engineer. Basically, you'll pick where you're going, and it'll pick the node for you if the node's open. When we do that, we can collapse down to only like 5 nodes. So what does that mean? Well, what that means is now I have all of these nodes here, Hammer 11 through 25, that I could use for something else. I could have different capacity. I can change the underlying system on them with Werewolf. And point is, we can test and do other things with them now, which is really what I want to get into. So a couple of things. One, we have these other operating systems that we can use. So if we come over here real quick, we'll stop this from spinning, and we'll say Werewolf. And we should just be able to go right here. I think it's node images right here. Tree main, yeah. So here's all the node images that we could use. We could use Alma Linux 8 or 9 if we wanted to. We've been using only Rocky Linux, but if people wanted Alma for some reason. We've got Debian, and then we've got Leap, which is SUSE, as is Tumbleweed. Those are both SUSE. And then we've got base Debian if we wanted to use it in one of these containers. So the point is we could bring that in and start using that if we wanted to on our system. I haven't decided which of those would be useful for us. Obviously, I think Rocky 9 is big because that's what a lot of people are deploying, but people are still deploying Rel 8 and Rocky 8, surprisingly. You might say, really? Yeah. They're still going to be supported for I don't know, what's the life cycle for them out to probably 2030 or so. Let's see. Let's go look at RHEL 8. Should be able to find that on the enterprise site for Red Hat, right? Here's RHEL 8. How far is 8 going out? Should be able to find it right here. Here's 8. Yeah, I mean, you can have 8.10 all the way out to 2029 before you even buy. Yeah, that's minor release, and then we're not even talking for that extended update support, right? They just have minor releases will still be coming out till 2029. So, you know, yeah, you're still going to be able to get support on RHEL 8 all the way out to there if you wanted to. And that's, again, that's, I don't know if you guys remember RHEL 5, that some people got off really slow. RHEL 5 was still getting supported like 5 years after its official end of life and extended support. Now, there is one thing that they say in extended support, and that is that they can cancel at any time, but they're not going to do that if some of the big fish are still using those systems. And the big fish that I know of that was still using it was the U.S. government, so they were still using it. NixOS is not there as far as this goes, and also we probably won't be using it, well, for a couple reasons. NixOS wouldn't be very good for me to give you guys as a lab machine because you guys can't do anything in it. You know, you wouldn't be able to admin it because it's a immutable box, 1. 2, as much as we'd like it to be enterprise grade, it is not used in any enterprises, right? Like I know of, I've heard one person tell me they were using NixOS somewhere, and it was a pretty niche little thing for them to use that. So I don't think we're going to see that in the enterprise. And I try to focus on the things that you guys are going to see out in the world if you're doing this stuff professionally. So I probably won't do NixOS. There's nothing wrong with the OS. It's perfectly fine. It's just not an enterprise type tool that you're going to find or run into. So, I mean, we could start working on that, I guess, tonight if we wanted to. I'm really just hoping my internet holds up, right? That's the big thing. Let's go check on Ranger. I'm surprised Ranger's not back yet. Thought Ranger would be back, but so we got that. The other things I thought to do was I have this presentation that I was working on last night. I was talking through this as the system went down, and this was you know, the theme of today's talk, or the theme of me being on right now, is Linux for fun and profit, right? Like, we do Linux for fun. It's a great tool to play with, and you know, we have it in our home labs and we do all this stuff, but we can also make money at it if we do sysadmin stuff. So I'll probably just go over some of this stuff and show you guys some sysadmin stuff in the industry. We have also, I'd like to point this out to you guys, we have a tremendous amount of stuff for you guys up in, you know, it's actually really funny. This is not in streamer mode. Normally this thing automatically pops over in streamer mode, but whatever. We have a whole bunch of events for you guys. If you guys want to go see, tomorrow there's a security project, security engineering project. That's for the course if you want to go see what the guys are working on. We've got security engineering study groups. We're going to, next week, we will be in Unit 11 of the Linux sysadmin course. Unit 11, we can go look at what that is here in a second. The security engineering course is officially done, but we're going to do one more meeting next week, this week, to talk through projects and work on stuff and whatever other things you guys want to do. Also, probably, I'm not going to do it tonight, but probably tomorrow I'm going to record the Unit 10 for that to put in the playlist. So tomorrow will just be 2 hours of brain dump on security engineering, right? There's a writer's room where people work on the course. Did you guys know you can get involved with the course if you wanted? If you wanted your name up here, if you wanted to be able to put your name here, oh shoot, where's that? Hold on. If you wanted to have your name here at the end of the course, right? There is a section where the contributors are all the people who have worked on the course. Here's the people that have worked on this course. Donated a lot of hours. They can show this to somebody professionally and say, you know, the person might say, well, why would I think that you know how to document Linux? And why would I think that you know anything about Linux administration? And they're like, oh, well, I'm the one who put together this course. I'm a major contributor to this course or whatever. And that would be, I think, a good way for them to prove that they worked through all of these topics. But Unit 11 is going to be monitoring systems. We're going to be digging into how monitoring works, what that looks like, how we do that in the enterprise, all that kind of stuff, right? For the security engineering course, week 10, we're just going to do final and recap. We've done all these other things, and they're all in the book, by the way. I think the guys have mostly caught up on the book right now, too. Yeah, I think everything's all caught up. In fact, the last thing they got to do, I think, is put the recording in here. They've got the recording for a lot of the previous weeks in there already, so then you guys can go in and watch the recordings and do all that kind of stuff. So, all right, let's go back to here. So you guys have this syllabus if you want it. All right, so I think that's what we'll do tonight. Probably we'll just talk through some Linux admin stuff. I'll probably pull up the Linux boxes and maybe we'll go through them a little bit. Yeah, we're on Rocky 19. That's fine. It's good enough. All right. But right as we start here, I need to take a quick break. So let me go find my camera. Give me 2 minutes. I'll be right back. Gotta take a call real quick. It'll be real quick. All right, we're good. I'm back. Ali Muhammad said, "Is this a new sysadmin course?" No, this is just one of the things that I talk about sometimes. This is just a like one of the walkthroughs. This isn't tied directly to any of the courses. This is just a presentation I did. And I don't remember why I did this presentation. I think the guys were asking about sysadmin type work, and I was like, all right, well, let's hit the components that I think you kind of need to know to get yourself started. Now, does the course and the other things that are all free down in our Discord also help you with that? Sure, absolutely. I think they're very structured. They're deeper in these topics, but I think this will get you started, right? If you told me, hey Scott, I'm going to take my notes out and do some of the things you tell me, yeah, I think there's a lot of stuff here that if you had gaps in your knowledge or in your skills, because some of us are just hobbyists, but we want to be professionals, this would help you close that gap a little bit. Sure. So this is Linux System Administration. So the first thing about Linux Systems Administration is there's a lab portion. This is just from like our general talks. And in the lab portion of any of this stuff, right, you would have to know how to power on servers and power them off. It's a very important skill. If I gave you this window right here and you were consoled into like the server as a virtual machine, this is a virtual console, right? You would be able to maybe go check the server and maybe reboot it if you needed to, or one of the servers people can't get to anymore. You could reboot that server if you needed to, or you can get console on it and that kind of stuff. And you could watch the server boot up and look for errors and all these kind of things that we might do as a sysadmin, right? Yeah. If you're doing the sysadmin course, Ollie, if you're working on that down in the Discord, that's the most complete thing I've got. This other stuff is all, just stuff that'll help you spackle in and fill in those cracks, on maybe where your game's at. So you got to be able to power things on and off. You got to be able to maintain inventory in a system, add, change, remove inventory. There's a bunch of places inventories can be kept. I like to keep inventory in Red Hat style systems. All of my inventories come from Satellite because Satellite's what they're actually charging us and what we can update. So Satellite is an excellent vehicle if your organization has the money for it. Excellent vehicle for holding on to all of your inventory. The next best place is probably a configuration management database, CMDBs. They are notoriously bad though. However, if you have the ability to connect to them over an API and update your servers, you should be able to just automate, here's my list of servers, and make sure that they're even and the exact same every day. And that's a thing that I used to always do. I would use Ansible to pull everything down out of Satellite. I would pull everything down out of our other tooling and verify that there was no differences in them. Because once I got that all cleaned up, every day if there was ever anything wrong, I could just report out to the team that was building servers and make sure that they had their proper final piece that checked them into, you know, whatever our inventory tool was or whatever Satellite was. Your devices are always going to be configured in Satellite, because if they're not going to get updates. So that's all there is to that. So maintaining an inventory system, you know, do you add stuff directly in? Do you automate this, right? These can be dynamic. Typically we decommission servers over time too. So we also have a life cycle where servers die as they get too old and can't be maintained anymore. And then you need to know how to install and update software. Do you know how to configure repositories? Do you know how to configure software to work within the cluster, right? Maybe configuring software is as you bring up an application, like one that I've had to do often is like New Relic. But then New Relic, to point at a certain application and then use an API key to feed data up into their system, has to maybe be configured with a specific API key for different applications. And you can write that right into your Ansible playbook so that as the environment is loaded up, it automatically goes and pushes whatever it needs to wherever it needs to go. So this is all something that's very not easy, but I mean it's very attainable for you, right, to be able to do. And then you got to respond to incidents, right? There's system level failures, there's security incidents. You need to be ready to deal with security incidents in your system, and you need to be able to deal with system level failures. A system crashes and goes down, and the last thing it does is send out logs as it's dying. You should be able to look through that and figure out what's going on, or as you try to boot the server, figure out what's going on with that server, right? These are skills that we need to work up to and develop as engineers, right? Let me see if I have, let me pull up real quick here in Unit 9. Let's go pull up back here in just the generic Linux group. Let me see if I have, there's a security incident response that I have. Yeah, so this is a little bit older talk. I'm going to jump over to this for just a little bit while we're talking here. I kind of been jumping around as we do these. When I originally wrote this, I was only a CISSP. I do have my CCSP now as well, if anybody cares about that kind of stuff, because sometimes people care about that kind of stuff. I don't really care too much about that, but it does show that you've went through a program of a body of knowledge, right? And cybersecurity incident response kind of looks like this, right? This is that perception versus reality. You're doing all of these things in security, but people aren't really looking for the black hat hacker that gets in. They're not looking for them, so they just get in and do whatever they want, right? So this is going to deal a little bit with like a specific incident type way of doing things, right? If you guys want to play a game at the end of this, we can do the Black Hills Backdoors and Breaches game if you guys want. But if not, we'll just jump back over to systems admin. But this is incident stuff, right? This is important. This is part of that other component piece that I was just talking about. We're just kind of going on like a little side quest, right? So what happens is we'll talk about what's considered a cybersecurity incident. What's the inevitability of it occurring? It's going to occur. You're going to get them. I get them all the time. We can pull up cybersecurity incidents happening in my lab right now, people trying to log in, right? We always have people trying to log in. We can discuss the practice of how to increase the effective response within an organization team, right? So you're responding to incidents. You need to understand what you're doing, right? Can't just be a fire drill where you're running around like Bender going, abandoned ship or whatever. I have a meme for that, but I don't have it set up with this newer. All right, so anyways, what is cybersecurity? Let's get some of those boring terms and concepts out of the way. What are the central problems of cybersecurity incident management? What are the things that most companies run into and have problems with? And then what constitutes an incident? What is the life cycle of a security incident? What are we doing? And what should we be doing? Like, do we understand what our company wants us to do? Or do we just run around like chickens with our heads cut off? It's not pretty, right? You don't just want to be, you don't want to be, I always tell you guys this as sysadmins as well, you do not want to be trying to figure out your tools as you're called out in the middle of the night. You do not want to be trying to figure out your tools in the middle of a security incident. You need to understand your tools and already be familiar inside of your systems. If that means getting at the command line in labs, if that means getting on dev systems and just typing in commands and practicing, well, that's what most of us do to get good at this stuff, right? Once an incident is occurring, what are we doing? Most people don't have a plan, and then most don't even practice their plan. So do we have a plan? Do we practice our plan, right? Do we have specific incident procedures that deal with something happening? And if we don't, we need to write them. Because what if I know all this stuff? What if I'm some brilliant, I'm like Troy or Achilles in Troy, and I'll just fight anybody and I'll just fix any problem? But what if I'm not there? What if it's somebody else? Remember when Hector comes and kills his nephew? If you guys ever saw Troy, kills Achilles' nephew, and he's like, "No, that wasn't me. Now you're fighting me," and he kills him. But that's like what it's like. You could be the best guys. You could be the best sysadmin in the world. You could be the best systems engineer in the world. You're not always going to be there. You're going to take a vacation one day, and you need to have your junior engineers and the other people need to carry the same weight as you. Otherwise, you're going to get compromised when you're gone, and it's all for naught, right? It doesn't matter if you're the best. You have to be able to rely on others too. Jake Seck said, "Hey, Het, hope you're doing well. Recently moved to a new team where I'm doing more true sysadmin operations. Wondering which killer coda or other source you recommend for learning EKS. Little to no Kubernetes experience." Okay. EKS, there are labs out there on the AWS side of things, but if you just want to learn Kubernetes, because under the hood, Kubernetes is Kubernetes, you're just going to have to learn some different stuff. I would tell you just get on Killer Coda, and then inside of Killer Coda, you can find a fair amount of things to start off, and I would probably starting out. So EKS is going to do a lot of the stuff that a CKA would do as far as like updating the cluster, making sure that the software is there, because it's all managed by AWS. You're just running the Kubernetes on top. So I would tell you to start with the CKAD. And you say, well, why? Well, because this is all the deployments on top. This is much less concerned. CKAD is much less concerned with like what's going on with the versioning and all that kind of stuff and the setup. This is much more concerned with the deployments that are happening, if that makes sense. Your Helm charts, your versions of Kubernetes, and making sure that, if you've got a manifest for 1.27 or 1.27 and we're on 1.31, the differences there are too great, and it's possible that something has changed in the syntax, so you might need to be able to move it forward, that kind of stuff. So this is where I would get started if it were me. Up here in the CKAD stuff, I'll link this for you over on the Twitch side. I'll link it on the YouTube side too, just so you guys have it. But this is like EKS is Kubernetes light, because you don't do as much of the like you're not doing CKA level stuff. Typically, you're doing CKAD level stuff, which is the laying all the systems and stuff over the top. If that makes sense. Also, this is my home lab. Let's check how the home lab's doing. Anything not working right now? Yeah, everything looks good. Okay, let's get that out of the way. So that's the agenda for what I'm talking about, and then I'll go back. I'm going to go back to the Linux admin course when I get done with this. This is just me burning time right now talking about stuff. So some basic security concepts. You need to know about the CIA triad: confidentiality, integrity, and availability. But you don't need to know about them as just boring CIA. You should know them as confidentiality is who can see the data and who can disclose the data. Well, if they can see the data, they can disclose it, right? But that's the point. Integrity is who can change the data, but it's not just who as a person. It can also be entropy and time, right? The slow passage of time wears down and degrades tape, right? If you have tape sitting there, and if you go to read your tape 10 years later and you can't read the data on the tape, does it matter that somebody changed it or not? It doesn't matter. You can't get back at the data anymore. Hey, Hack the Planet, how's it going? And Ray Host, thanks for the first time chat. Hopefully this stuff's useful to you. We're just going through, we're doing Linux systems administration, but I jumped over to a talk about cybersecurity incident response that I've given, and we're kind of going through that a little bit, and then we're going to jump back. So this is cybersecurity stuff, right? And then availability. Is the system available for all the times in use that it should be? And we tend to take availability as a representation of a number of nines, right? 4 nines, 5 nines, and there's a really good high availability Wikipedia article that shows you the levels and costs of that kind of stuff. Okay. So we keep coming down. Security events are anything that happens, can be documented, verified, and analyzed around security. A security incident is an event or series of events that adversely impact the ability of an organization to do business. And security intrusions are evidence of an attacker attempting or gaining access to you. So security events are anything that happens. Let me show you guys some security events that are going on literally right now. In my home lab, we've got logs right here. And if you guys have not seen logs before, this is a log of the last 6 hours. And these are people that have failed to connect into my DMZ. I have a SSH, well, my Bastion sits in the Bastion in the DMZ. And that's how people connect in. And these are the users that have been attempting to get in the last 6 hours. Sometimes we have like many, many hundreds of these. And they get themselves locked out forever with my IDS, right? Fail to ban is technically an IDS and an IPS if you want it to be, right? Intrusion detection and intrusion prevention. This is our intrusion detection. Intrusion prevention is over here where they get banned forever. And they do get banned and then we never let them back in, right? So all that kind of stuff. Rayho said, hello, I am new here. I've been working as sysadmin for a year and I've been practicing for taking the EX200. So RHCSA, we have somebody that just passed that today in our Discord, and we have like 2 or 3 people that are studying for that right now in our Discord. So if you do want to join the Discord, they're down there working on it. For almost 4 months, but I still don't feel confident enough to take the exam. Well, we have guys that are down there studying for it right now, Ray Host. And if you want, there's our Discord, and we're almost to 4,000 people in there. We're like right at like 3.9 something. We got a cool little bot that Fisherman provides. Hold on, let's see. Let's go to our general here. Yeah, 3994. So we get a few more people in there. We'll be at 4,000 tonight, maybe. Who knows? But anyway, so here's our security concepts, and these are things that are happening in our system, right? Events, incidents, intrusions are the things that have actually happened. So these are some concepts, right? And companies are going to play with these a little loosely, but this is pretty much generally the way we look at this. Okay, so damn, didn't listen to your whole answer. The ad appeared. Well, you got the Discord if you want it. Awesome. Well, you're welcome down there. Guys are always talking about stuff. I think up in certification topics, you should be able to find stuff in there. All right, so I'll wait till people come back from break to move forward. But these are our security concepts. These are things that we need to kind of understand about what's going on in our system right here. And people should be back from the break, so let's keep going. Those are security concepts, right? The security events, incidents, and intrusions. Like I was saying, they could be a little different, but for the most part, they're like that. And then Ray Host, yeah, I was just saying, hop down the Discord and go look at the certification channel. Guys are in there working on that stuff, and then sometimes they have study groups and stuff. So, all right. So then the security incident response lifecycle is going to look something like this. By the way, this is the same incident response lifecycle that most people use for everything. We detect, we respond, we mitigate, we report, we recover, we do remediation so that it doesn't happen again, and then we have our lessons learned. There's a bunch of terms that come up in here as we're an operations team and we're doing incident handling of whether it's just regular IT incident or security incidents. And what happens is we start to develop this over time. We start to track how long it takes us to detect things. And that time to detect is called your mean time to detect, MTTD. Your mean time to remediate or fix, mean time to resolve, as some people do it, MTTR, might be over here, and that is your aggregate time of the whole process, right? And then there's all kinds of MTTs, right? But they're mean time to detect, mean time to resolve, mean time between failures, MTBFs. Those are things that we know for disks so that we can do math on how many disks should be failing in the average day. Shunya over on YouTube, how's it going? We're not really doing anything important tonight. We're just kind of hanging out and talking about Linux for fun and profit, right? We're kind of hanging out, and I was talking Linux sysadmin, and then I jumped over into incidents so we could talk security incidents a little bit, and then we'll jump back over into Linux sysadmin. We're just hoping my damn internet holds up, because again, last night my whole Cox internet went down, then I jumped onto my other internet, but when I do that, I can't get back. When I jump internets, from one to the other, I'm jumping over Wi-Fi, so I lose all of my connectivity into my home lab when I do that. My home lab wouldn't have been able to talk out anyways, so we would just been self-contained. But anyways, what are we doing, right? We try to detect things as quickly as possible. How do we detect things? Well, we've got intrusion detection systems, and we've got SIEM. SIEM is your security information and event monitoring, and those are things that are chewing through your logs, right? Your logs are going to, in my case, tools like Loki, right? This is Loki logging right here. And we're just looking for failed, but we could have triggers where if failed happens so many times in like over a 5-minute period or something, it triggers an alert, right? So we can do all kinds of things in here. And because we can do this, and actually there's a lab that shows you guys how to do this in our Killer Coda. We got a lab that shows you guys how to trigger. In that case, it's when fail to ban triggers. But that's an intrusion prevention system firing off and locking somebody out and then alerting out anyways. And monitoring and alerting are their own thing. But detection is the idea that somebody sees it. Maybe you got a network operations center at work and they look at these. Like I've told you guys, like we just use little revolver tabs here inside of Google Chrome. And we just revolve through every 10 seconds all the stuff in the environment. Oh, Ranger's back on his bed. Look at him. But we can monitor all the stuff in the environment, and maybe we go, aha, that's high. We need to track that. We need to alert out to somebody. So it could be that, but humans make mistakes and humans miss things. So we tend to want to write those things into some type of management. We want to have it automated. So we query things with our SIEM. Our SIEM can track things. Good free ones. There's a tool called Wazoo. We have that in our lab, but we don't really use it for much. I might start porting some of the labs in there, or the logs in there, to start checking stuff, because that would be a fun little tool to use for that. SIEMs that cost money are like Splunk. Splunk is one that costs some money. Another one that tends to be considered a SIEM is if you send logs into like Elasticsearch, or use this Elasticsearch, Logstash, and Kibana. That's a way to build a SIEM solution. Elasticsearch is often OpenSearch now because it was forked by AWS a while ago. Amazon forked Elasticsearch off to OpenSearch, and you guys can go look into that if you want to see what happened there with the business source license. But there's other things that kind of go into this a little bit. What was I thinking about with that? We have detection, SIEM, all those guys. Let me think. Had something else I wanted to tell you guys about that, but my brain's not working right tonight, so we'll just skip it for now. But your response capability, then, a lot of what you're doing comes from your policies, your procedures, and the team. You have to have a team defined, but you also have to have procedures. Like, just if I just told you guys right now, drop everything you're doing and fix this system. Here's the login. I mean, obviously I'm not going to put any of you guys to work, but even if I tried, there would be probably a lot of like, well, I don't even know what that system is, and what am I supposed to do when I get over there, and what powers do I have, and I see I'm root, but I don't really know where you wouldn't really know what the server was supposed to do or any of those kind of things. So we need to have policies and procedures, and I always tell people, if you don't have that in your organization, right, then you have to be the one to make it. And the way you make those, if you don't have policies, right, like if you don't have an acceptable use policy, if you don't have a bring your own device policy, if you don't have I use this as an example all the time, and it might seem kind of crass, but it's very valid. It's a very important thing to think about if you're in tech. If you don't have an acceptable use policy on your machine, what's to keep somebody in your organization from just watching porn at work? Think about it. I know it won't say the word porn, but my little thing won't. But I just wanted to think about it for a second. Is it against the law? No, not in most cases, right? Is it distasteful? Sure, probably to half the people or so, maybe even more. But my point is, are they breaking any rules? I mean, maybe they're using more bandwidth than they should, but I mean, there's no actual law against it. So why is it wrong? Is it wasting company time? Probably. I mean, they're probably not doing what they should do if they're watching that. But maybe they're an excellent worker besides that. Maybe they're the best worker you got, and you don't have a policy against that. Well, you can't fire them. it's going to be a nightmare if you fire somebody for something that's not against your acceptable use policy. So what you want to do then is go figure out how to build them. So sans.org has a whole bunch of information security policies that you can use as templates. Here's an acceptable encryption standard, acceptable use standard, and you can go right in here to the doc. Look, I can download the doc. I've done it many times before. But right here, I can pull up. Here's my sans.org acceptable use standard for our system. I don't want to do any of that. Come on, get out of here. And here's my acceptable use policy for sans.org. It says right here, this content is subject to the use of the served. So they have legal terms and conditions, but you're allowed to use them. This is actually new. They didn't used to have this on here, but these are they're basically free to use, right, within your organization. So that's one that I really like showing people. And then, but that's policies, right? That doesn't help us with procedures when shit hits the fan. They've got another thing over here, sans, and they have the cheat sheets. And the cheat sheets are awesome because they give you a general list. I'm going to link this to you guys that might need it. I'm going to link this to maybe some people that need it. This is not what I would call cookie cutter. This is not a one-size-fits-all, just throw this at the wall and you fixed cybersecurity. This is not that. But if you needed a cheat sheet for what you should be doing as a server administrator, right here, here is what Windows over here on the left. This is all Windows on the left. And then this is Unix and Linux on the right. And you could take this and say, okay, when we get in there, we need to start checking and saving off these. We need to look for security events of people logging in here. We need to examine if the network is the same and no extra networks have been added. We can look for connections to outside networks, and maybe we do all of these. Maybe we even have a script that just dumps all this. There's a script called, Linux state, or, Linux security breach, whatever script, and it runs and it captures all of these things into a file, almost like a little SOS report, and then dumps it off somewhere. That could be something you write, but the point is, you could take this and start to turn it into a set of procedures that like the junior engineers do, or the junior admins do in your company. Here's Windows stuff over here if you want to do Windows stuff, right? But the point is, there's all kinds of things for you to start modeling your organization's procedures around, okay? GPike, these are kind of, it's kind of like a generic template for you to build from. GPike, that's another thing. Junior engineers tend to, or junior admins even before they're rolling over into tend to move up into engineering type roles. They will be doing, if they don't know how to do something, they will be using pre-baked templates and pre-baked procedures by senior people that have done it before, or other people that have at least done it before and turned it into good documentation for them. So those are templates that you guys can use, And then you have to have a team. You have to have a defined team who needs to be called out. Typically, a whole team is not on call. Like, I just got off of on call for NOAA, right, for NOAA weather, and that's NOAA, and I had been, so I had been the primary on call. But then if I needed to, I could escalate to any of the specialists on our team. I tend to be Linux and deployments and Ansible and storage. Those are kind of my things. We got guys that specialize in networking and different components of the system that if I had needed to call them out, I could have, but I'm a single point of contact to my part of the team, right? And then incident response and handling, how do we triage? How do we set what's the most important things? Who's in charge of that? Who's in charge of investigation? How do we handle data? Once we're starting to capture things, how do we investigate that? And does investigation ever come before containment? No. You need to get your system fixed, and you need to get whatever's in there out, and you need to get back to a running system before you're worried about investigation or root cause, right? Those are things that come later. You need to have that stuff saved off in logs, and forensically speaking, you need to have those things protected in like a read-only mode, right? And then analysis and tracking, we need to know what happened and when, right? Those are always important things. What happened? When was it? If we can know what caused it, like what kicked it off, and those kind of things. And then after recovery, we need to recover and repair. And then in that step, in the recovery and repair and what we call remediation, we need to ensure it doesn't happen again, whatever it was, One that's real big on remediation is something happens in the environment, you close off some port, you stop something from happening, maybe you remove a tool that was compromised like log4j. Then you need to go back in the remediation. This is a critical step that typically doesn't happen until Monday. We don't do this on the weekend when we fix the systems and they come back up. We'll go back typically on like the Monday, and we will re-update all of the servers and all the base images that we have to remove that problem. So that problem is never redeployed on new servers back into the environment. We never want that to happen. In fact, that's one of the most stringent things security teams have come up over the years against me as a Linux engineer, is like, hey, or when I'm like the Linux lead or the platform lead, they'll be like, hey, we cannot reintroduce things. And I'm like, well, you're right, absolutely. But we have to work that into our pipeline, right? We got to go back and fix the original stuff. So yeah, log4j, man, that one. So log4j, if you guys remember that, would have been what, December of 2021. When that one hit, it was like so there's CVSS scores, right? It was like a CVSS score of like a 9 the first time, I think, and we all patched it out. And then it came back as like a 10. It came back like 5 or 6 times as different types of vulnerabilities that people were finding around this log4j. Most of us just figured out how to rip it out and use a different tooling, right? But it was a hassle when it was there. While we are in this process, if this takes longer than an hour, we need to know, who are we escalating to? Who are we feeding information up to, and what are the people that are authorized to send external communications? One of the things I always tell everybody when somebody asks me anything security related is we need to understand as quickly as possible what the scope is of data that are being stolen or have been stolen. And people say, what's the timeline to notify you? Well, typically you have like a regulation, like within 30 days you need to. There's some HIPAA compliance things. If more than 500 people have been breached, you have to notify them within X amount of days, and you got to notify the government within X amount of days. But I'm just going to tell you this. There's this one general rule I always say, and that is this. The customer should never find out from the news or from somebody else, like outside of the organization, that they were compromised by your organization. They should find it out from you. If they find it out from you, they may trust you again. If they find it out from somebody else, they will never trust you again. What was that? What was that company that was down in South America somewhere? They're a big company, but they were down South America, and they like lost people's data twice and never even told. They lost millions of people's data, and they never even told anybody. And then they got popped, right? And people found out about it later, and it was bad. So G Pike said, when things are functioning and running smoothly, is your job just to research and consider theoretical paths that breach system? That's one thing. What's another way that we do things? A better way that we do things is we lock things down to start. So we have secure technical implementation guidelines, and we have benchmarks and different things that we do to get the system to a certain level of security compliance. And the idea is more like this. The system can only be connected to on TCP or UDP 0 to 65.534, right? Those are all the numbers that can be connected to, right? And those are all the port numbers. And why don't we just close them down so only like 3 or 4 that are needed are open, like 22 and maybe 443 and maybe, I don't know, you're using node exporter, so like 9090 or 9100, whatever you're using, right? So you only open those ones, and then you monitor those to make sure only valid traffic comes in. And if you're really nuts, if you really want to go for like the big security standards like zero trust, you're not really nuts if you do that. But what I'm saying is now you only accept connections from devices that you have authenticated via TLS that they should be talking to your devices. That's next level security, but that's kind of what the standard is right now for a lot of big stuff. So yeah, we deny all allow by exception policy. Yeah, we block all traffic. We're like, no. We're like Matumbo. No, not in my house, right? You're like smacking stuff down. And so that's the common model is we close all the shutters and we watch the couple of entrances, right? Right. It's the infantryman's way, right? Guard your fields of fire, as it were, right? But anyway, and then mitigation is limit the effect or the scope of the incident. We want to get things off of talking and spreading and whatever we need to contain things. And then mitigation may be moving stuff around or any of that kind of stuff. So, G Pike, thanks for the thanks for the subscription. You're probably trying to ditch ads. Make sure you refresh your browser so you don't get any more ads. I know that Twitch can be kind of aggressive on ads, and the best I can say about that, the best I can say about that is one of the things about Twitch is if you don't run ads, you get pre-roll ads, and pre-roll ads are like the worst thing ever. If you jumped in the channel and it was like 2 minutes of ads up front, nobody would stick around. Everybody would just leave. Thankfully, I don't get any of those because I use Turbo. I can't be watching Dead by Daylight and have it keep cutting out of there and that kind of stuff. So, all right. So, anyways, this is the general idea of a security incident, right? This is how we look at them. There are various variances and fluctuations and things that you might deal with, but these are the general things that you're going to run into in terminology. So we could play a game to kind of practice this a little bit. The game is by a company called Black Hills InfoSec. They're very popular. Most of you guys have probably heard of them. They're like a big security. And we'll play a modified version of their game. But here is their rules to this game. This game is called Backdoors and Breaches. Has anybody ever heard of this? Anybody ever heard of Backdoors and Breaches? Skip verification. So here's what Backdoors and Breaches looks like. It's a game where somebody, me, an incident master, gets to make up a whole bunch of stuff about what's going on in the environment. I'm just going to make stuff up. No, I've got a general set of rules that I go by, right? And then you guys are going to be running the incident as though you were the engineers working through it. Okay? Does that sound fair? I think that's a pretty good way. Zoaz over on YouTube said, when is Linux admin 16-week cohort starting in 2025? We're actually in the middle of it right now. So we are, all right, let me show you guys where we're at here. We're in week 11 now, so it's probably going to end around the end of July. So it'll be the end of the 16-week course, somewhere around July. We got a big conference coming up in the beginning of August. That tends to have like a few hundred people at it. It's pretty fun. We have different speakers come from all over the industry to talk to you guys about how they got in the industry, what they do, tell you guys about that kind of stuff, what they think you should be focusing on. So the next running of the course, if that's the case, we originally ran it last year starting in September. So maybe this year we'll also start it again in September, if that works. I think because that would be September, October, November, December, and then we'd probably finish up in January again. So that will probably be the next start. It will be the probably in September now. Because what are we? We're already in June, right? So we just got July, August, September. It'll start up again. But that being said, everything for that course is already out there. Everything for the course is already out here, right here. You guys could start going through it now if you wanted to. Hell, you could even try to catch up if you wanted to. There's a lot of work, though. It's a lot of work to catch up. And we're already down here, so this is what we're finishing up in that course right there. Okay. But anyways, this game is going to be me, an incident manager, and I'm going to tell you guys some stories. You guys are going to be the defenders between 1 and 7 players, and you guys are going to have, you're not going to have any actual cards. I do have the cards sitting up there, though. I do have them sitting up on my, if you guys want to see what the cards look like, but they look just like this. And we're going to go through this little game and practice as though we were having an incident. And you guys can tell me what we're going to do. And we're going to roll dice. We're going to roll a 20-sided dice like we're running some early advanced Dungeons and Dragons. And we're going to have to roll to hit at armor class 0. Does anybody remember Thaco? To hit an armor class 0? And that confuses people sometimes. But anyway, so we're going to do that. And let me grab, I had forgotten that this was in here so quick. But we're going to practice some incident stuff and see how you guys feel. Wasn't on such a grandpa schedule. Yeah. Well, Colcus, if you got to get some rest, get some rest. We've done this before. We've run through this before. But we'll play a modified version of it. And here's some things for you guys to think about as I'm over here prepping. Give me a second. Let me go grab the answers real quick. These are some things for you guys to think about over there. And I'm going to pull this up. 1, 2. and then 3. Let me get this out of the way. Okay, so I've got 3 different versions of this scenario. Oh, Quartz one with the gifted. Thank you for that. Is that 10? Jeez, that's a whole bunch of people that aren't going to have to watch anything for a while. I appreciate that. You guys are always welcome to just hang out, but I do appreciate when you do stuff like that. Keeps me motivated, keeps everybody else motivated. Make sure you thank your gifter if you got anything kind of, you know, if you got anything there, that's that. Yeah, thanks for that, Quartz. Yeah, we hit that, and we're so close right now. If people keep joining the Discord, we are so close to 4,000. Oh, we lost somebody. We're not any closer to 4,000 than we just were. All right, we're not closer. All right, so so let's walk through a little bit of this then, and I will tell you guys the story as we go, and you guys can sit around and think about how you would like what would you be doing in this incident, right? This is for you guys, right? So it's for you to think about. Easy money, yeah. Log4j definitely hammered a lot of real companies. They really got hit with it. All right, so you guys can read all this. This is Richard Clark was a very famous kind of like early what became like director of Homeland Security type stuff, and then he said that to a bunch of IT professionals very early on in the 2000s. And then Mike Tyson famously said, everyone has a plan until they get punched in the mouth. Like, everybody thinks they know how it's going to go, and then they get punched in the mouth, and they have no idea. And then General Patton said, a good plan, violently executed now is better than a perfect plan executed next week. He's a real general, right? And then this is a fake colonel that doesn't really exist. He said, you're never ready, you go when you're ready enough. Does anybody remember that quote? Does anybody know who Colonel Graff is? And Ender's Game? Does anybody remember Ender's Game? You remember the goal of Ender's Game? You had to win. That was it. You had to win. There was no other choice. It was civilization versus civilization, right? Like you had to win. All right. So anyways, and then let's play a game. So here's the thing. We're going to be dealing around 4 areas of probably compromise, or however you want to think of it. There's the initial compromise of our system. I'm going to start telling you guys a story here in a second. There's the pivot and escalation once they get a foothold in your system some way. Then there's C2 and exfiltration. So C2 is command and control of your systems, and how do they actually exfiltrate and pull the data out of your system. And then persistence is how do they have that persistence to be able to pop back up repeatedly. Remember we were talking earlier about remediating and controlling your environment again? Well, how are they going to be able to be persistent to pop back up if they need to? So think about that for a second. And here we go. So here's the story, right? And I've got the answers over here. They'll start popping up as we kind of get through it. But you know, you're the IT manager of a medium-sized company. You probably have about 200 employees, a few hundred servers. And you come in the morning, and as you walk by, you get your coffee, you walk by the knock, and you can see the lights up on the wall and stuff. And one of the network operations center, the manager sees you and starts waving you down before you even get to your desk. And he runs out and he goes, hey, we got a call from our ISP earlier. Our web servers normally get, they're normally flowing about 80% traffic out on web requests, but currently it's about 50-50 traffic, and they're actually taking a tremendous amount of traffic in, and they're using all kinds of different ports, and it's like so much so that our ISP called us because this is very strange. So Linux developer, did you have a gifted sub too? I didn't even see it. Well, either way, I appreciate it. Hopefully this stuff's all useful to you guys. That's the goal. It ran out. Oh no. So here's so you're sitting there, you're coming in to the organization, you haven't even sat down yet, and somebody's already telling you something's going on. Something's happening with our web servers in our environment. And you know this is a big deal. You know this is something that if they've called you from the ISP, this is so aberrant that you need to figure something out. But you go down to your systems and you tell your IT people to start checking on things. What are you going to focus your engineers on when you sit down? Talking about the initial compromise, that's all the information you've been given. What are you going to start to work on? Oh, and the procedures you have are on the left there. Your procedures over there are on the left. The ones that you can choose from pretty regularly. Now, as you guys try to do these things, there's a certain amount of challenge to this, in that we're going to roll. We want a 20-sided dice right here. No, we don't need a 4-sided dice or 6-sided dice. Get out of here. Go. Get out of here. All right, there we go. As you guys try to do it, we're going to roll a dice to see if you actually successfully do it, or if you derp it up and miss it. So, yeah, that's a technical term. This is your thing. So what are you guys going to do, considering what I just told you? What would you be trying to do in your organization right now? What would you be trying to do to figure out what's happened to your systems? Yeah. Well, it's a technical term, right, derp? 5, you'd look at internal segmentation. Fair enough. Let's roll. You rolled a 5. You have a procedure for it, so that's +3, so that's 8. That's less than 10, so it fails. Also, that's not necessarily the thing we would want to do best. So what else might you do? You know, we've got our system here. We know that move this over a little bit. It's kind of, I'm like right in my way where I'm trying to wave my hands. We know that these are web servers that we have out there in the world. What up there might we go and do to look at our systems to try to figure out how they were compromised, or if they are compromised? Like just the traffic patterns are weird on them. Something's going on with them. We don't know what yet. What are we going to check? Yeah, the pane. We're doing backdoors and breaches. Yeah, this is a modified, like, backdoors and breaches. Yep, absolutely. In fact, I had it right. Well, I just had it right here. And I have the actual card game over there. When I show engineers this game, they always love it. This is like one of their favorite games. It's such a good way to show people how hectic incidents can be. By the way, one thing that we always do as we talk about this is, do you know where any of these are in your organization? Do you know what these are? Do you know how to do a server analysis? Because if you don't, you need to think to yourself, I'm not trying to like pick on anybody here. I'm just telling you, if you're somebody that's going to be called on to do these things and you don't know where the procedure is and you don't know how to do it, it's going to hurt. You're useless in this instance. And I'm not trying to be mean to anybody. I'm just saying our goal as engineers is to not be useless. So we need to know how to make ourselves less useless. We need to learn these things. Is it 10? We could try isolation. Let's try it. You successfully did it because you have the policy here, +3 and 15. But that doesn't actually find what's happening in the system, right? Now, remember the DMZ, your web servers are out in the DMZ, so they're exposed to the world. We expect them to be exposed, but they are still just servers, and they are sending logs in. So we can do server analysis or log analysis. So let's roll one of those. And we would have failed drastically. So when you fail 3 times in a row, either in picking or this and backdoors and breaches, what happens is I get to do something like say the logs are gone forever because one of your interns erased all the logs on accident. We're not going to do that today. We're just going to go through and say there was a web server compromise in your organization. You guys have been popped. You got popped by somebody. And this is how we would typically find that in an organization. The attackers have taken over an external web server. They found they were just script kiddies running some type of Metasploit against your version of HTTPD or Nginx, and they found a way to leverage it, and they found some storage, and they started uploading and rehosting a whole bunch of you became basically part of a net that was sharing and seeding back to BitTorrent. That could be what happened. But what they did was they took over an external web server and they pivoted to your internal network. So now they've taken over a process and they've escalated in some way, and then now we would have found that via server analysis by looking at our servers and seeing logins and seeing what was happening with our processes. That was one way it could have happened. We could have looked at logs, so security incident or security information and event monitoring log analysis, so Splunk or again Wazoo or one of these tools to get our stuff in, or real-time. RITA is Real Intelligence Threat Analytics, which is typically the same type of tooling, and sometimes those are specialized tooling. I think backdoors and breaches Black Hills Security might even sell something like that you guys can buy. So there's a little bit of sales to this, but not necessarily for me, but for these, for somebody else that's trying to do this. So they've taken over your system, and the next thing we know that's going to happen if they've gotten one of your systems is they're going to try to pivot elsewhere in your network, look for tasty data that they can get out of your system. So they're going to try to pivot and escalate their permissions. So what are you guys going to check next for that? What are you going to check to see if somebody is escalating and trying to pivot through your organization? Yeah, the pain, the injects, where you get to, I got them all over there, but they're so funny. They're like somebody tripped over the power cord and now you have to wait 20 minutes before the server comes up, or the one that I always remember is one of your interns deleted all the logs. I always thought that was funny. That's not possible if you're sending your logs off properly, but if you're not, there you go. So now what are we going to do to watch for pivots and escalations in our organization? We know that they've taken over something that was sitting in a DMZ and also had an internal facing IP. What are we going to start looking for them to have tried to get into our internal network? What are we going to start doing? Well, of those 10, or if you have others. By the way, when you ever do these live, if you do these live for your organization, if you can pull up a policy in your organization that you would use, it counts as any one of these 10. So it counts for a +3 on your rolls. So I think it's kind of fun. It's like a nice little way to do it. So what else are you doing, right? That we've seen them take over our server. We now know that there's a problem. We're probably starting to isolate those servers and save off the memory and do snapshots of what's going on so that we can stop the compromise. But we have to think that they've pivoted and escalated into our network. What are we doing next? What would you do next? This is, right, if you've never practiced this is good practice. What would you do next? Would you start looking for maybe other devices that are being touched? Maybe we do some endpoint analysis to look for attacks on your workstations and other servers, or even I would do even more log analytics. Connections outbound. Do you see that here? Well, we already know that they got into the systems and we're doing that, so we're already closing that down. Yeah, we've on our main web servers, we're already taking care of that right here. So we're shutting that down. That's coming down. But what do we think they've probably pivoted into? They didn't stay there and wait for us to get them. They're doing other stuff. So let's say that we did something like endpoint analytics. So we rolled a 6 + 3. We didn't do it. So let me send a better engineer over. All right, he gets it. And what happens is they found a vulnerability in your systems and they switched over to root. You were running containers that were not immutable and didn't have no ability to go up to root. And when that happens, what happens in your system is maybe somebody pops one of your services and they escalate up to a root user. This is the most common thing. We used to do this in the early 2000s. We would do competitions. People call them commonly now like capture the flags, but we used to just root the box. That was a competition we used to do. Root the box, take over the server. Top Rack, hopefully this stuff's useful to you. Thanks for the Prime subscription. You can use that anywhere. You choose to use it here. That's always fun. Plus, you don't have ads anymore, so that's kind of cool. So we see that they've taken over root access, and that's a problem. But now we know that they're going to use some type of command and control to try to pull data, exfiltrate data out of our system. So what are we going to do to check for that? What are we going to do to check if somebody is pulling data out of our system in a way that they shouldn't do it? Remember we had that traffic earlier that was 50-50? We could start examining that traffic, but what would we do internally? Obviously, we'd be getting calls out to the our ISP and asking them what they know and what logs they can show us. Obviously, we'd be doing that. But what could we do internally to try to track down this command and control and exfiltration? What might we do? Might we do some more of this real-time? By the way, Zeek is a really good one. Zeek is one that I've used professionally. It's a really good tool for tracking all your network traffic. So let's say we tried 9. NetFlow or Zeek. Zeek is a free and open source tool, right? FOSS. Or RITA, real-time real intelligence threat analytics. Let's go ahead and say that we tried that. And we were very successful. We rolled a natural 19 plus 3 is 22, so we got it pretty good. And we find that, and maybe our ISP gets back to us a few hours later, hey, almost all that stuff is coming out on port 53. That's super weird. Why is there so much DNS traffic coming out of our network? It's not because it's DNS traffic. Port 53 on the destination going out could be going anywhere, but normally you don't filter for it. You don't filter for DNS because DNS could be going to so many places that a lot of companies don't even bother looking at it. But there's such a high volume of it that we find that they've been using DNS as the command and control channel for them to both exfiltrate data and to keep a persistent connection outbound for them to be able to talk and control the servers. So that's a problem. But then, so you clean that up and you maybe block that and you clean up your IP tables, you know, and make sure that filters are there for things to go out of your system. And DNS can only go to maybe the 8.8.8.8 of Google and maybe the 1.1.1.1 of, you know, whatever. I think Google might run that one as well. There's a few different ones that are out there in the world that we can connect to and look at. But now we want to check for persistence. Anybody that's worth their salt in any way, once they control your system, they've done their compromise, they've pivoted over and escalated up, they've started to steal data and take control. They want to be persistent even as you're trying to scrub them out. They're like that blue algae that gets in people's pools, and you try to scrub it out and you end up having to like take part of your pool out to get rid of it because it's so persistent. That's what people want to do. They want to be stuck in your network. I've heard of people being in like NASA systems in like the early 2000s. I've heard of people being in NASA systems for years and years before they ever got rooted out of anywhere. People didn't even know they were in there. They were just in there and communicating and that kind of stuff. So I'd assume traffic volume was logged somewhere. Yeah, top rack it is, but a lot of times people just assume that DNS is safe. DNS is so oftenly assumed to be safe that it's a common DNS or a command and control channel. And I'll show you guys that if you guys want to see that. We'll talk about where we get these from if you ever want to see those. It's tac.miter.org. But what's the persistence? How would we find if somebody was persistent in your environment? I would argue this one is also server analytics, but let's roll. And let's say that we were doing, nope, we failed. We need a better engineer on it. 11 plus 3, 14, that's higher than 10, so you pass. And the last one for this is maybe the attackers install a logon script. Maybe when they had root for that little bit, they put something in etc profile.d. They just put a little script in there that every time you log back in or any user comes onto that system, it automatically opens a channel back over port 53 to their command and control. And maybe that's just the common way that they know that any server is ready to take commands and give them data. And that could be something that could be triggered by any user on the system, right? Now, how might you block that? Well, one, always make sure that you have only the things that should be in etc profile.d there. Maybe you keep track of that. Tools that would be useful for that would be AID, AIDE, which is the Advanced Intrusion Detection Environment. This is for Linux. We've got a lab on that. If you want the AID lab, if you're like, hey Scott, I do want to go play with AID a little bit, it would look like this right here. Do I have Killer Coda up? No. Go to our Linux labs, and I have an advanced one on AID that we did during the Linux Security Engineering course. Where's he at? Let's STIG remediation, UFW. Oh, where was... Oh! I didn't do it as... I apologize, guys. I didn't do it as a... it's going to be under Unit 8. But I didn't do it as its own thing, so I'll have to give you guys this instead. It's right here in the lab. So in the lab, I just make you go right here to one of the Killer Coda things. So if you guys want it, here it is. This would be where it would be in here. Oh, shoot. Hold on. There or there. So if anybody wants that, it's there, but it's also in the Linux course. I haven't made that into its own lab yet. We just did it as a lab in the system. So, all right. So that's the first scenario right there. That's what it looked like. You had an initial compromise. You detected something wrong via either your own tooling, or in this case, you got a call from your ISP. There's some fuckery going on. There's something that's not right. You guys went in and started finding it with either server analysis to see that servers were not behaving like they should. Maybe you're doing some stuff like this, and maybe you're doing a SAR-N TCP and ETCP, you know, 5, something like that, and you're just watching for numbers of TCP connections. Let's go 1. And you're just looking for connections, and you're seeing too many active or passive connections, or maybe you're doing netstat -ntulp, and you're looking for connections. Maybe you just want let's just do netstat by itself, and you're just looking for connections. See if we can see all connections, and maybe our system to be connected out to different places. You can go and check that kind of stuff with your tooling, right? You can do TCP dumps if you want and watch traffic flowing around in your system, right? But the point is, you found that there was a compromise. You looked for where they went by looking at endpoint analysis on systems or on endpoint security protection analysis, so things trying to connect. This could also, as I said, have been server analysis, because they might have been on other servers that were normally connected to. C2 and exfiltration, how are they getting data out? You would use real-time, real intelligence threat analytics, or I would also say your Zeek would be able to track that kind of stuff. Zeek just does an awesome job of tracking everything that's going on in your network. It's a pretty good little tool for that. And then their persistence is you go and you look through what login scripts and other things have changed in your environment. So this is a way to kind of see what's happened and changed in your environment. Okay, so scenario 2. We'll do another scenario. Let me go find this scenario. Pull it up over here real quick. So I have it. I got to remember the story that I tell for this one. Oh, all right. So this one. You get a call from the CEO. He is playing on his laptop, right? And he has gotten an email from one of his nieces, and he opened it up, and he clicked on it, and now his computer's very sluggish and not working the way that he expects it to. So he's called you up, and he's told you guys about it. But the email that came to him was from his niece, and it had very specific information about him that made him open it, because he thought it was for him. And now his system's having problems, and he's called you guys out, maybe the desktop team, to come out and look at his stuff. And what would you be doing if he was having problems, and he's having problems after he clicked on something in an email? What would you guys check for your CEO if that happened? Well, reimage is definitely one of the best things that could possibly happen. But he's already clicked on this, so let's start to say that there's something probably wrong, right? What do we think could have happened here? What is it when somebody targets your CEO or your bigwigs in your organization? Anybody know what that's called? It's actually kind of a funny term. What's it called? Somebody's targeting them. Maybe somebody's targeting them. Right? Well, the phishing is generic, but what is it when they're going after the big fish? They're probably phishing off his email. All right, so we're going to check something to do with his system and maybe emails, right? So what happened was, you go to find out, they sent a malicious email targeting users, and the CEO opened it. CEOs are going to CEO, guys. There's an old saying in this world, you rise to your level of incompetence. So he opened it, and he compromised the system. And you know that whatever happened got his credentials. Logged into his system, got his credentials, right? He clicked on the wrong thing. There was malicious code in there. And you might have found it through a firewall log review of traffic that was coming in. Maybe things were blacklisted that shouldn't have been coming into your mail server, your MX exchanges, right? Or MX is your mail exchange, right? Or your endpoint security protection analysis might have caught it as he tried to execute it, but maybe it was too late. And, it's called whaling. When they go at the big guys, it's called whaling, right? But yeah, spear phishing is very targeted for sure. But I think they call it whaling when it goes after the big wigs. So we know that something's happened in the environment. We know that the CEO, most powerful person in your organization, had his credentials taken. What are you doing next to try to track what's going on in your environment? What are you looking for? Top Rack, do you want to hear my favorite social engineering story ever? This one will probably remain my favorite forever. I'll tell you guys while you guys are thinking about what you would be doing to try to find the next one. Yeah, so when I first got out of the Army, that was 2003, I started working for a school district, so this was now 2004. And I remember I was always reading articles about IT, and I was in college at the time. And what happened was the IRS got an audit. And in this audit, they called, all these guys did, they just called different IRS agents and said they were from the IRS help desk. We need your password. And 50% of the agents that they called gave the password to these people over the phone. Gave their personal password. This was like 2004. Gave their personal password to the person that called and said that they were IT. They were ecstatic. The results of this came back. They were ecstatic. Do you know why? They were ecstatic because the training had worked. Only 50% of them, 50, gave up their password when asked. The year before they did any training, in 2003 when they did this with the IRS, 90% of them did it. I know where I was in 2003. I was in the Army, but I know that I've been on the internet since 93, down in the library. I would go and get on the internet. I wouldn't give shit for shit my password. You could call me right now. You could have a video of my grandmother's dead, but you could have a video of my mom talking to me right now, and I wouldn't give her my password. She could be like, this person's going to kill me. And I'm going to be like, that's unfortunate. This could be AI for all I know. I'm not giving you my password. I'm not doing it. Because, by the way, if your password's ever compromised, you can never use it again for the rest of your life, whatever that password is. Because it will always be somewhere forever. Yeah, it was a 40% drop in the users, in the IRS agents or whoever they were calling in the IRS. People at some desk in the IRS, you know. And, yeah, it went from 90% the first year to the training knocked it down to only 50%. 50% of the IRS agents. This was in 04. You can go look the study up. I find the study if you guys want. Drop it in our. We've got a section for like academic stuff because I often do academic stuff. It should be right here somewhere. People move this stuff all around, so I can't ever find it anymore. Academic topics right there. We can drop stuff in there. All right. Anyway, so what are we doing with this guy? Well, we're going to go. We know that he was compromised, his user. So we're going to go look for. Oh, look, we did it perfectly. We're going to go look for user and entity behavior analytics. So we're going to look for his user trying to log in places that he shouldn't. And the only way we're going to be able to do this kind of entity behavior analysis is if we're properly tracking logs throughout the organization and bringing them in. So we can look for his user, or we can look for passwords to be used in places that they normally shouldn't be. And we find out that the attackers start a spray from his desktop to every IP address that they can hit. Every known network that he's connected to, every secure thing that he's been able to get into in our organization, he's trying to get into all of them. Even ones that he shouldn't be able to get into with his user. It's a password spray, right? And you would find this through user or entity behavior analytics if you have that. Remember, if everything in your organization is going back to your LDAP or your Active Directory to check, now you have a way to see that the CEO tried to log into all 300 computers that your small organization has. Why the hell would he do that? We don't give him access to Linux. He doesn't even know what Linux is. He thinks that's just something like a budget item. So, we know that they got in on his system and took over his user. We know they sprayed the password everywhere. They're going to use some type of command and control to try to get data out of your network. What are you going to do? What are you going to start checking to see the command and control and exfiltration of data in your environment? Well, G-Pikes, I can tell you that the CEO is definitely not doing nothing because he's definitely checking emails from his grandkids sending him funny cat videos. So he's definitely doing something. Don't think he's not doing anything. He's doing something. It might not be what we think are productive, but he's doing something. It's like It's like the old keep my name out of your mouth. Like, no, he's definitely doing something, guys. Don't besmirch him. He's doing something. All right, C2 and exfiltration. What are we doing? What would we check? What would we want to see if we know somebody is going to have some kind of connection or pipe or control in some way through our system? How might we check for that data to be leaving our system? And by the way, this next one that I'm about to show you when this pops up, this is you're going to find a major reason why a lot of companies turn this stuff off. Because I hear it all the time. Oh, why do they turn that off? There's no reason I can't check that on my free time. Oh, there's a fucking good reason for you not to check that stuff on your free time. So there's that. Yeah, he's playing Minesweeper. Over 443, it's possible. So let's roll, and let's say that okay, we would do whatever it was successfully, but let's say we did some analysis of the network to see traffic going out. And what if I told you that one of the most common ways to get data out of a network is this one right here? Gmail, Tumblr, Salesforce, Twitter as a command and control. If you leave Facebook open or Gmail, we expect a lot of encrypted traffic to go through that. Now, this is different than Gmail that's used for like the enterprise. This would be like a separate Gmail. You're allowing them to connect to just open Gmail. Well, that can be used for command and control from companies, right? If somebody has gotten them to connect to something that they shouldn't, there's all kinds of things that can happen. And I'm not trying to just bash on Gmail. Facebook's the same way. Facebook is a lot of encrypted traffic over Messenger. People can use that for command and control of systems, right? So the attackers route traffic through third-party services. This is one of the most common reasons why people just turn this off. If anybody's ever come in and told you just blanket turn that stuff off, they're trying to save you the headache of this. They're trying to just like say like, I don't have time to explain to you all the things, but this will make most of them safe. There's an old thing when I was early on in my career, and even till recently, I've been the platform engineering lead, so I tend to still have Windows under my control, even though I'm a Linux guy. And on that Windows stuff, I can tell you one of the number one things that used to always be told is don't let people be admin on a Linux box, or on a Windows box. It's true on Linux box too, but on a Windows box, don't let them be admin. And did you guys know that like if you had like an aunt or a grandma or somebody that was always having problems, if you just made them not the admin user, you made them just some average user, and they had to press a button to become the admin user in some way, you would stop like 99.5% of all attacks that they ever ran into, and things that they clicked on would no longer be effective against them because they're not the admin user. Did you guys know that? That's been true for like 20 years in Windows, right? So anyways, all right, so what would we do to check for persistence? What persistent thing might there be? And let's just say that that we already found it, but one of the big ones would be like his device got compromised. So we're fixing his user, but let's also check his device out. And 10 plus 3 is 13, so that's higher than 10. So the persistence here might have been that they installed plugins in his browser, so when he goes and clicks on his funny cat videos that his cousin or that his nieces and nephews send him that are not related to that bad email, just the regular ones, anytime he now opens his Firefox or his Chrome or his Edge or whatever he's running, he's got malicious browser plugins that automatically reconnect him and go back into command and control and log into a phony Gmail and start moving data out. This is the kind of things that happen, right? So we need to think about these things. But we went from initial compromise, he was just clicking buttons. They pivoted and escalated into the password spray. They started exfiltrating any data they could get through Gmail so that you wouldn't recognize it. And then they stayed persistent by putting plugins in his browser. All right. One more. Let me go move this over here so I can see it. All right. Huh. This one is probably the most common one. So let me show you guys something real quick. I know we're just playing a game here real quick, but let's go over here real quick. And let me show you guys, if you've never seen this before, if you've never seen the diamond model of intrusion analysis, I'll link this to you guys that want it. Can't delete the internet or install tech support. All right, so if you've never seen the diamond model of intrusion analysis, this is the way that we share incident reports in the industry. You'll see a lot of people use these. The government uses this. If there was an actual intrusion of some type, this is the model that's used. There's the adversary versus the victim. This is often called the socio-political axis. And there's the infrastructure versus the capability. That's the infrastructure of the attacker versus the capability of the defender, and that's called the technical so this is the socio-economic axis, and this is the technical axis, but there's a name for it, techno-capable axis or something. There's a name for this axis, but this is the two axes that are used right here. And then you can go read about that. That's an excellent read to put you to sleep, but there's a lot of things that are built off of the diamond intrusion model of analysis. So if you've never seen that before, that's the official way that we kind of look at this for when we're passing this information around to each other, or we're reading an official report about something that got compromised on a system, right? And if you're dealing with ISSOs, information system security officers, that's the type of reports you're going to see from them. I've read those for Target reports and Sony and some of these other ones that I've modeled some of these attacks over. This one right here, the one that we're about to do, this is the most common type of compromise I've heard of Fortune 500 and like bigger companies. Like big companies, this is the way they get compromised. Not universally. None of this is universal, right? But this is the way that they've been compromised the most, the way I'm about to show, or the way we're about to do, all right? So that's exactly right, G Pike. You have, the way that we consume data, if we know, it's the same thing. Like if I were to pull up stuff and start showing you guys how we do like literature reviews, like I'm working on my doctorate, right? And how do we do literature reviews so that we can consume research material quickly? You know, you read the abstract, you make sure it's about what you want, you jump down to their conclusion, see if their conclusion matches and is not necessarily matches where you're going, but matches what you're looking for. Then you jump up typically to like their methodology and literature review, and then you read the paper if it's useful. If you start at the abstract and it's no good, don't read it. If you get down to the conclusion, you're like, that's not really that's not really the way that I'm going. It doesn't matter if it aligns with your conclusion or not, right? You don't want to read in a freaking echo chamber, but it's, then this isn't really the paper that I need for what I'm trying to work through. This isn't what I want to cite and actually spend my time reading. And if you keep having these stage gates, you can consume a lot of research material very quickly and you can knock out a lot of research material that's not important to you. So anyways, we'll do that in one of our research things one of these days. I'm going to start kicking those back up in the Discord for people that want to work on, I'm going to be working on my doctorate, but for people that want to be, I said doctorate, but I'm going to be working on my dissertation, and I've got 60 pages of that written or whatever. Anyway, sorry, let's do this. So this is probably the most common. You get a call from a third-party trusted company of yours. You guys have business agreements in place between how you share data over an intranet between you. You have APIs and servers that communicate with each other, and they call you up one day and say, we've been compromised. We believe they've passed off into your network. We believe that there has been a side channel, horizontal crossover into your network because of some of the things that have because of some of our systems. So you now have to start figuring out, what are you going to do to figure out what's happening with your system. And in fact, actually, it's funny. The way I originally wrote this, I don't even think I was supposed to tell you that the third party had a breach. But I don't even think they were supposed to tell you. But for the purposes of this, they call you and say, we've had bad stuff on our network. We think it's spread over to yours. You should start checking. What are you guys going to do? What are you guys going to check? What would you guys start looking at? I'm going to grab another water while you guys think about that. Maybe a couple waters. Did I turn off my camera over there? All right, give me a second. I'll be right back. Go grab me a couple waters. You guys think about what you would do. You get called by one of your vendors. Maybe you don't even get called by them. You just start seeing weird traffic. What are you going to do? Excuse me. All right. Let's say that you were going to start looking at all the user accounts that you've worked on with them. And it looks like we'd be successful in that. Well, if it's an API, it's anything, that can get a token. So maybe it's like a Vault instance that gives somebody a token. It could just be, because what actually is a user in your environment, right? I mean, users can be service accounts. They can be applications that have checked out a token and can authenticate that they are who they say they are. And something's been compromised. So now you're looking at what happened. And what happens is they take advantage of a third-party breach. So they took some other vendor that you trust to come in on the side channel, and they've gotten into your organization with their passwords. They've been able to start to do things. And you would find this typically by looking at your servers for API calls and things that don't look normal and connections that don't look normal, and then user and entity behavior analytics for how those tokens are trying to connect and what APIs they're trying to hit, that kind of stuff. All right, so you determine that there's been a lot of stuff that's not supposed to be happening in your organization that has been happening. And now you're going to start to think about how they might have pivoted into your organization. You see the servers they've hit. They want to pivot into your organization and do other stuff. What do you think that they might, how might you figure out what else they're doing? Maybe in your server analysis even you found this. Let's see if your guy did well enough. Yeah, he did well enough, sure. So what you find out is that they create and load their malware using a service with system privileges. So they have some type of root privilege, and they can make a service. So like if we were looking at a Linux box here, maybe in my home lab here, in here, maybe they made this Scott Ansible configure. They wouldn't make it this obvious, but they've got like a single one shot that makes a playbook that every time your server comes back up, they're back under control of it, right? Maybe that's something that they've done. So they've got a service that is set to come up. Let's see. And this thing it's dead, but it is enabled, meaning it's going to fire off when it goes again. And it's a one-shot service to just run some code. Who knows if that's malicious code or not? I mean, we might happen to know that that's an Ansible playbook, but how do we know that that's not just reconfiguring our service to go talk to their stuff? That might not be good, right? That might not be healthy for us. So pivot and escalation, they have some system privileges, and they made a service that's always going to start up. So what type of command and control and exfiltration might they be using in your system? This next one might be a little more on the Windows side of things, but this can affect you on the Linux side of things as well. So how might they pull that data, command and control and exfiltrate data out of your system, and how would you find it? What would you go look for next? By the way, this one's always the same. It's always number 9. This one's always 9. It's like a cheat. It's always real-time, real intelligent threat analytics, or Zeek, right? So, okay, you did it well enough. And this one is, they're using a tool called Bits. That's a Windows service. Almost always ignored in the network. Let's go look. Let's see if my Linux box accepts that. Do we see Bits in here compared to... Actually, I'm not even sure. Let's go look on the Windows side of things. Background intelligence transfer services. That's what's used for updates, right? WSUS as well. What's the Bits port? I don't see the port number there. I don't remember this stuff, guys. I'll go reference it, right? Typically recommended is 8530. Bits is seen as standard HTTP traffic. By default, it goes over 80, but you can change it to 8530 if you want. WSUS also uses port 80. So it may be undetectable because it's using the same thing as port 80 by default. That could be a truth. I don't know exactly. I don't know that much about the Windows service, but I know that it's common enough that it gets ignored, and if it's port 80, that makes sense. Port 80 generally gets ignored. So, yeah, Bits. Yeah, Samba is one, Top Rack, Samba is one that used to get compromised a lot. We used to turn Samba off a lot in networks. If you're not using it, you should turn it off anyways, but we used to turn Samba off a lot. I think 2 was always a very valid one to do, by the way, G Pike. All right. So last one, let's just roll out. Say we did the last one. How would we check for persistence? We'd look for that user, that endpoint analysis or that user login. And it says that what they did was they put a simple malware service that starts every time the system starts. Well, that was always part of any system privilege. If you had a system service inside of Linux and you set it up to be on like that, it would always be on and it would always come up unless you went and turned it off. So unless you knew to go check for these ports and services like this that are on, this will always fire in my environment. Always, this will always go off. If my system reboots, this always fires at least once, and then it sends a home lab reboot alert into our Discord, so we always know when my systems reboot, right? And we do that. We do that for a reason. We want to know if things get compromised. All right, so there's that. All right, so anyways, that's questions. That's that part of the lab. But we did that as just security, and so that was all just, if anybody's been here for the last hour and 30 minutes, we started this talk and we got to here, and then I went over into that other talk. So now that was just security incidents right there. And that's only scratching the surface of it. We only played around a little bit with it. We didn't even dig in on any of those topics that much. But there's a lot of information around being a good Linux admin, a good sysadmin and stuff, right? We're back. It's like you just woke up from a dream and now you're back here. And Scott's at the beginning of the presentation again. We get to start. You're stuck all night with me. I'm like, you guys ever seen the first Spider-Man? I know it's not the first one ever, but I'm saying the one with Tobey Maguire, and Macho Man's like, I got you for 3 minutes. And they close the cage down on him. He's like, I got you for 3 minutes. You're not going nowhere. Or I think he says anywhere, but it doesn't matter. This section focuses on okay, so then we'll talk about the sysadmin stuff. We always talk as an administrator like the big four. You guys will always hear me mention the big four. Some of you are probably tired of hearing me talk about it. But it's CPU, memory, disk, and network. In an environment, in a server, when I go to a server, I want to know how much CPU is being used. What's the wait time on the CPU in this case? Maybe if I have IOStat, I can see how much the system's being used for the CPU, right? That's a common thing. And we want to observe, benchmark, and tune things in that order. Observing things, running commands, almost free. It's almost free to just check stuff on a system. It doesn't cost anything. Very safe. You go to a server and it's kind of slow. You can just sit there and it's pretty safe to do things on it. But when we start to benchmark or load test systems, we don't want to do that on live systems. We want to benchmark or load test systems that are not under heavy load with production yet. In fact, we do a lot of benchmarking. We use LinPack. LinPack is a common tool. I'll show you guys LinPack if you want. Pull this up. I'll just use this roll of dice from earlier. LinPack is part of the top 500, so different ways that we run. Let's try it this way. Maybe it'll go this way. So LinPack. If you need LinPack benchmark, here it is. This is the standard by which we run high-performance compute systems against. So if you ever hear about supercomputing or high-performance compute and you're like, how do they track what the fastest ones in the world are? It's all based on the LinPack benchmark. And you can go read about it. The goal is to have the highest number of floating operations per second across the system. All right, so that's what the algorithm looks like, and you can go look at it and dig in as much as you guys want on that, right? Well, I talk about that a little bit in our high-performance compute talks, which I'm pretty sure I have that up on YouTube somewhere for people that want that. Is benchmarking done to check new hardware, ensure it runs as anticipated, and then use on systems at different life stages to ensure that they're still able to handle their expected loads? Yeah, G-Pike, what we tend to do is, we benchmark a system when it first comes out to see what its overall capabilities are, and then we also do individual LinPacks on nodes. And it's funny you say that because we do benchmark individual nodes to make sure they're within 5 to 10% of the original benchmark for tolerance before we put them back in the system. And I actually was doing that today with a bunch of servers on NOAA. Servers go down for maintenance, they come back up, and we move them through different stages until they're ready to be released back to production. But the test is, are they within 5% either way of their original benchmark? And if they're not, they don't go back into service. We have to do something else to fix them. We need to switch out RAM, do whatever. But yeah, that's exactly what we do. And a benchmark for me, a benchmark is when I actually hit the gas to the floor and take the server as fast as I can. That's a benchmark to me. A baseline to me is how does the system operate under normal load? So a baseline for me on a Friday afternoon might be 50% of the system. But we talked about if you're like a gaming company, guess when gaming companies get a lot of load on their servers? Friday afternoon when kids and adults get off of work. I want to make sure I don't go off camera here. When they get off of work and they don't have homework and they don't have work the next day, so the server load goes way high because a lot of people are playing the video games. That's always been a common thing. You got a lot higher load on a Friday and a Saturday night in a server company that runs video game servers than you do on a Tuesday night when everybody's got work the next day and homework. I mean, it's almost like that's silly to even talk about, but it's true. It's something you consider if you're in those spaces. But that's your baseline. Your benchmark is when you hit the gas and go as fast as you can to see what the system's capable of, right? Electricity usage is the same. Yeah, I live in Phoenix where there's massive usage of electricity during the day because, it was 107 today? It was only supposed to be 104 today. It got to 107, I think. Wait, let me go check. Make sure I'm not lying to you guys. I saw for sure my phone said 106. It's a lot. It's a lot. But observe, benchmark, and then tune. Tune is always, so look, this is observing, very safe. I can go on my servers and I can do see just like that and then just run that for the next 60 seconds, and that's pretty safe. That's not even going to put the system through its paces. It's not going to do anything. But if I start to change things, like if I tune profiles or if I were to set C groups to a different size of memory and CPU usage and block off and cordon off the resources in the server, if I'm doing that, that's much more dangerous. You're tuning a live system. You're changing the way that the network behaves on a live system that's maybe a database. Oh no, you're asking for, you tune like free mem pages on a running Oracle server or something. You are asking for a crash. That's why this is red. Don't do this if you don't know what you're doing. Don't do this on live systems. You can do this all you want down in your test bed in your dev environment before it gets to test or QA. Beat your systems up all you want down there, but do not do this to live systems. And by the way, this is another important thing to note. It's very, very hard to load test a server in a dev environment because in a dev environment, you will never get the real true load of your customers in a live environment. You just simply won't, right? You're used to getting 5,000 API calls a minute on a server. That's pretty low, but 5,000 API calls a minute on a server in prod, but the most you can drum up on a dev environment, like, without just hitting the same call over and over again, is like only like 300 because you just can't generate the same type of load you can in a production environment. Made you think of the old Battlefield 2 Friday nights? Yeah. I'm sure Blizzard experienced that a lot over the years too, because remember the old BattleNet? I bet BattleNet used to get popping because I had friends that played. I never got to, I played StarCraft, but I never got like super into StarCraft. And I had a buddy that was like top 100 in the world on that or something. He was wildly high up on it. And and he just loved playing BattleNet. He was always on it though. He never really stopped playing that. He was always on. But anyways, tune. This is one I'm constantly telling you guys. We look for utilization, saturation, and errors. Utilization is always. So utilization of a system, if we're here, is always 0 to 100%. Right? And then as you get to 100%, so if we were utilizing the system at like 70%, that would be a utilization of 70%, right? So utilization is always 0 to 100%, always. But when you get to 100%, you start to get to saturation and you start to queue out and there's a wait or a line, right? There's a line forming to use that resource that's now under load or waiting. Did you guys know when you look at this? Oh, hold on a second real quick. Oh, you know what? My pen is there. That's what the problem is. I'll keep them real quick. I didn't mean to do that. So let me get this out of the way. Let me show you guys something real quick. So actually saturation is as you're waiting for the system. I want to show you guys something here real quick. Did you guys know that this is utilization right here? So this is how utilized you are. And we're not hitting 0% idle or 100% usage in some way. So this system is sitting somewhere around down here in utilization, right? But saturation is actually shown over here. And this is why I always tell you guys, uptime is actually a saturation check. And a saturation is the number of processors you have. So I have one processor in this box. Right? And if we just watch this for a few seconds, if my system was under high load with one processor, in the 1 minute wait here, anything higher than a 1 in this field right here would represent saturation occurring. Right? Utilization would be shown here. Saturation, this is wait time against the number of processors you have. And you say, well, what's high then? If you have 1, anything higher than 1 is something is waiting for that processor. Same thing with this command here. vmstat right here. This is the number of runnable processes, and this is the number that are being blocked. Oh, hold on. So here's our runnable processes, 3, 3. There are no blocking processes, and there's nothing waiting right now to use the CPU. See that? So these are runnable processes, and these are blocking processes. And you might say, Scott, how do you know that? It's not because I memorized it. It's because down here, I can go look for, right? And this says, if we don't have it here, I have it over there. Yeah, there's the number of runnable processes, and these are the blocked ones. So runnable processes running or waiting for runtime. If that's ever higher than the number of CPUs that you have, things are waiting. And the number of processes blocked waiting for I/O are the ones that are standing in line. So did you guys know that you could use, some people don't know this, but I'm telling you right now, you can use vmstat to know how saturated your CPU is. And you're like, but vmstat's supposed to be looking at memory. It is. But it can tell you, even if by accident, the number of runnable and blockable, or the runnable and blocking processes in real time. So you can know that. So I think that's valuable. What does the percentage user mean? Okay, hold on. It's a good question. Right up here in IOStat. So in IOStat, so there's 2 types of space that really matter to us. There's user space and there's system space. User space are user space calls to the kernel, and system are system space calls to the kernel. That's it. So user space and system space. Your user, and by the way, this is actually really important because watch this. What if I say sleep 10 and I'm going to put a time on it? So did you guys know you have a little stopwatch in Linux? You could use a stopwatch at any time around a command. So I'm going to sleep for 10 seconds. I'm going to get 3 values out of this. Watch this. My system's not doing anything while it's sleeping, right? Do we agree with that? We're going to get the wall time, which is the real time. Then we're going to get the time that our system was doing system calls. And then we're going to get, user calls in user space. And then we're going to get the time that our system was doing system calls in system space. Right there. Our system wasn't doing anything because we told it to go to sleep, so it didn't use any processing. But that clock, that stopwatch is one of the best things that I ever found in Linux, because I use this to determine how long things take, and then I tell my engineers, you know, if something's going to take too much time. Watch this real quick. I'm going to time dd, and dd is the disk duplicator, and the in file is going to be dev random. So we're going to take random bits off the processor. We're going to say out file is equal to dev null. It doesn't even matter if I do that, but that's fine. And then I'm going to pipe this. We're going to do a block size of 1024K, so 1 meg, and count of count is going to equal 3000. So that's 3 gigs of data. We're going to pipe it to gzip2. Gzip. I don't think we need -2. And we're going to say -9. And then we're going to throw it into dev null. So we're going to generate a bunch of random things, random numbers, 3 gigs worth of them. We're going to compress them and throw them away. This is going to take our system some time to do. Probably, if I had to guess on this one, if I don't crash it, because I could crash it. Let's say I think that's going to take like 30 seconds or so. I don't know these things. There we go. It took 12 seconds. But it took 3 gigs. It grabbed them random bits, ones and zeros off the processor, and it compressed them down with the highest level of compression and threw it out. And it took 12 seconds to do it. And it barely used any user space time for system calls or kernel calls, but it used a whole bunch of system time. In fact, the whole time was system time because it was compressing a bunch of bits and stuff, right? So anyways, I did that to show you guys that you can test these things. You can see how well your system does things. And you could standardize these checks against a bunch of your servers, and that could be part of your checks on your servers, right? Yeah, I actually have in the course that we're doing, right? And guys, I'm not trying to sell you anything. The courses are free. But in the course here, when we get to next week, we're going to be doing system baselining, benchmarking, and testing. I'm going to show you guys a bunch of the same stuff, but in the course. So if anybody's doing the course, it's free. It's in Discord. All right. Observation tools, you've got uptime. Uptime shows when the system was last booted. That's very important. Like, I want to know when the system went down and came back up. And then it tells me the load average of 1, 5, and 15 minutes respectively. It's a good indication of if a problem is still going or if we've gotten to that problem late. So I'm looking at some server that's been up for 40 days, and this server has 32 cores in it. So being at under 0, there's no wait time on this processor. So the server's chilling, right? Come down here to VM stat. This is that same one we were just looking at. He's not swapping. That's very important. He's got a lot of memory free. This box has like gigs and gigs of RAM. He's not using that much in buffer or cache, so he's fine. Yeah, swap in and swap out is not being used, and IO to disk is not being used. So we're pretty good right now. You can see all these things. If your swap is being used, you're probably out of memory, and that's super bad. You don't even want to use swap anymore nowadays. Sometimes we're forced to turn it on for like databases and stuff, but you do not want to be swapping live. Swapping is the idea that the system has run out of memory, and now it's got to start going to disk. Well, when you're using memory, right, your processing happens at a speed of 1 relative to everything else in your system. So your processor is a speed of 1. Whatever that 1 is in gigahertz, it's 1. And then everything else is a ratio of that is slower. So what I mean by that is if you can access things in real time perfectly across your CPU at a speed of 1, when you're out on your RAM, that's 1/10 or slower of the speed of your processor to go and access that and pull it over and read it and do computations on it, right? But when you're out of RAM and you're going over here to disk, that is 1/100th the speed of the RAM at the best. Sometimes it's even slower. Actually, that's one of the reasons SSSD is so good, is because it is a faster access, but it's still not nearly as fast as being in RAM. So you don't want to ever be swapping if you can avoid it. All right. So anyway, so then there's some breakdown of different things in the system, kernel idle wait. I would tell you to read the man on VMstat if you ever need to dig into those more, but I think that that's kind of good. Exactly. Yeah, sure. Okay, so we come down to VMstat. Now we got MPstat. MPstat's nice because it shows you which processors are actually getting hit. This one right here at a high level, you might see a really, really high usage against all your CPUs here. But down here, you might only see one CPU being used, CPU 0. This is often used for the system space. And then, like, let's say we're using a tool like Weka. Weka is a very common big data system now. Maybe 1 through 4 are allocated to Weka, so now you can't use them as normal processing. So then you're only using like 5 through 20, 32 or whatever, 31, whatever you have in your system. Well, where I'm going with this is when you look at this at face value, you just go, okay, well, nobody's doing anything in the system. Who cares? But wait a minute. You have some developer developing some research app that hits the weather, right? This is one that I run into often. And they'll tell me, hey, Scott, this seems like it's not moving as fast as it should. And I go to the system and I see the 0 is being used for whatever, and 1 through 4 are not being used, but maybe the first Slurm allocated one is 5, and that's the only one that's getting hit. And that's the only one that's getting hammered for CPU, and it's up at like 1700, some Java app or something. This is common. But they thought that they had hyper-threaded it and it was going across all of them, or multi-threaded it and it was going across everything. And that's not That's not what the observable behavior is, right? Does that make sense? So you come down here and you go, well, something's wrong. This is what we're seeing. Whatever happened with that job submission or whatever, something's not actually splitting out and going across the different processors. Maybe they got to rewrite their code. This gets even more complex when we talk about job schedulers going across multiple nodes, because now you got to go check all the different nodes to make sure they're also multi-processor across all the different nodes. And then that's another thing that'll cause, because, and one of the reasons we have to know how to troubleshoot this as Linux admins is the researchers aren't going to know how to troubleshoot that. They're just submitting jobs to their Slurm job scheduler. They're like, well, I found this code on the internet, and you're like, well, that code was wrong when you stole it, right? That was. Anyways, so that's where MP stat's useful, is what's being used against what processor in your system. And I routinely work on systems that have like over 128 cores in them, so I have to be able to read this quickly and look for numbers and that kind of stuff. It'll be really obvious if something's not threaded properly across multiple cores, because it'll be really high here and it'll just be high on one of these. So it's kind of easier to see. All right. PID stat. PID stat's good because it shows you exactly which command is running against exactly which PID, and it's a rolling per process summary. It's useful for watching and recording patterns over time. This is, man, I can't emphasize to you guys enough how much Java is a black box to a Linux engineer. When I troubleshoot and try to help my Linux or my Java guys, it's all just it's almost like there's just like a black balloon sitting here of all their processes and memory and stuff, and I'm just the Linux engineer with a platform that it's sitting on. I have no idea what's going on inside of their Java virtual machine. I don't. But I can see what CPUs it's touching, and I can see what disk I/O it's doing. So in that sense, I can help them if there's some kind of capacity problem or some kind of, that kind of stuff. But at the highest level, I can't troubleshoot that well unless there's errors and alerts and stuff coming out of there, right? So, okay. Yeah, look, Java process is just gobbling up fucking one. Are they on one processor here? I can't even see, but I can see massive amount of user space time. I don't even remember what box I was on when I was doing this, but it was just a mess, right? And this is a thing that you might run into, right? Okay. It's obviously an older Linux kernel, 4.10 or 4.1. What are we up on? 6.8 now on the newer Rocky. So, all right. Observation, IOStat. IOStat's really good. There's two things. IOStat-C is going to show you the processor stuff, and IOStat-D is going to show you block devices. Not always disks, block devices. Block devices may be disks, or they could be other devices pretending to be disks, like RAM. But anyways, here's all the block devices in this system, and then a couple loopback devices, and I can see the reads per second and the writes per second. This is just the raw number of them, how many reads and writes per second. Over here is the reads in kilobytes, capital B, per second, and writes in kilobytes per second right here, right? I can see if there's any, you have to look up what RRQMs are, I don't remember these right off, but it's reads something and then writes. But then we get over here and we can see if there's any errors. We should be able to see also the wait times. So are we waiting to get stuff? Waits used to be a lot more common, and these are spinning disks, so you'll see them. Waits are how long it's taking this specific read or write to get control of the head to actually go write on the disk, right? We don't have, so if you're not using spinning disks anymore, you're using all like SSD, you're not waiting that time anymore. So this number is still valuable, but it's going to be less. It's going to be a lot smaller number. Because the seek time on a disk is the arm headed the head over the platter. It's going to be the longer time for you to get to stuff. Okay. So then there's the wait and the average. Yeah, I don't even know what all these are. Yeah, and then there's some saturation if these numbers start going high. You'll start seeing these go red if you're waiting and that kind of stuff. So, I could have sworn there was errors shown here, but I don't see them here. So we must have errors somewhere else if we're getting a lot of errors on the disk. Okay. SAR is a good one. It doesn't mean synthetic aperture radar, not in this case, but it does sometimes. We can look at individual interfaces. We can see received packets and transmitted packets, received kilobytes again, and transmit kilobytes. and then some of the other stuff that's going on. Now that's if you just look for dev. You can also look for -n, and instead of looking at the dev, you can look at just TCP. So if you're looking for TCP connections and established sessions, that may be something that you want to know. And also TCP errors. So I showed you guys that earlier. That might look like this: SAR-N, TCP, and ETCP for like, I don't know, 10. Oh, let's go every 1 second. And this will go every 1 second, and it'll tell us how many TCP sessions do we have established, and are we getting a lot of errors. And errors may be indicative of network problems. They may be indicative of, well, you could get errors because of TLS problems if you have bad certs or something like that. However, this might not be the best way to find those, because those would just be, you're not connecting at all. But this is a place that I would go if I was getting intermittent errors over time, right? That kind of stuff. All right. SAR. So more about SAR. Yeah, this is TCP errors and stuff. Number of locally initiated TCP connections and number of remotely initiated TCP connections per second. So are we getting a lot of connections or not? And have those went to 0 when we're used to seeing like 500 a second or something, right? All this stuff becomes more interesting in light of what the past baseline is, right? So that's always good. Retransmits are a sign of network server issue. Maybe an unreliable network or destination server is overloaded and dropping packets. That's true. It's all true. Although when you're looking at TCP, it's segments, but we're not going to split hairs on that one here. In networking courses, we will split hairs on that, but not here, right? It's packets and segments. They're not as interesting to us on this level, but they do matter in a networking course. All right, what your terminology? This is probably, let's say it's 8, so I'll probably get done here. But observability for the big 4. These ones. This, by the way, this presentation's up in the Discord if everybody needs it. It's here in presentations, and then it's called Linux Systems Admin. It's right up here a little bit. Socratic Method Linux. People really like that one, and it's Linux Systems Admin right here. Boom, I'm not a liar. There it is. I said that because when I didn't have this done, I didn't post it, and I didn't post it for like a year, and then I finally posted it last year when it was all done. But these are all in there for you guys if you want to practice them. You can practice them up in the Rocky boxes and see how these different things work. But again, utilization is how utilized something is between 0 and 100%. Saturation is as a queue starts to form and you're waiting for access to the resources. And then errors are hopefully coming out of the systems as timeouts and other things are starting to hit their thresholds, right? Look for all of those things within these different systems. All right. This is the same type of thing. This is like what I would go check on a system. You know, what's the kernel version? What's the version of the system? How much memory do we have and how much is free? How many processors do we have? And nowadays you just have nproc. You don't have to do this whole thing like I used to do. But nproc will tell you how many processors you have and then how utilized the processors are with uptime. It's a surprisingly useful command. lsblock or block ID will tell you physical disk information, even if it's not mounted. Often when we talk about this, people say, oh, just use df-h. Df-h is great if something's mounted. But if something's not mounted, you can't tell. Like if I just said, hey, tell me how many disks are in that server, and you do a df-h, that's not going to cut it. Because what if they're rated up and then sent up to us with like logical volume management or something? That's lsblock and block ID will give you the actual block devices that are in a system, right? Yeah. Those aren't mounted. None of these are mounted right here. In fact, this stateless machine that we're using only uses these if you choose to build them out for the labs. Otherwise, these are all TempFS mounts up here. So you would look at this and you'd say, Scott, there's no disks. You're using all TempFS and an NFS share. And I'd say, yeah, that's right. But there are 4 disks connected to this. But they're not mounted anywhere. So it's something to think about, right? Something to play with. Running process hierarchy, you can use ps-e-forest. One of my favorite ones for how a system boots up is systemd analyze blame. If you guys have never seen this is so funny to me. Systemd analyze blame. And in chronological order, not, well, sorry, it's not chronological. It's not chronological order. Chronological order would be time bound. This is not time bound in the sense of, left to right through the passage of time. This is from what took the longest time. The WW client service took 5 seconds to come up, but that doesn't mean that it started at the beginning, and it doesn't mean anything compared to the overall system analyze. If you just do this, it'll tell you startup finished at 1 minute and 40 seconds. That's a long time for a kernel to come up. It's a whole long time. And kernel was very short, but user space was really long. So what took so long in user space? We can go figure out what was happening in the system, right? I always like this one as well. Well, system, if you want to know how SSH started, right? So we can see SSHD running, but did you know that you can cat that? It's one of my favorites. And you can see user lib systemd system sshd.service, and that's the service file that was called for this server to start SSHD that time. Now, user lib systemd system is not a place that's safe for you to change. If you go changing stuff in here, you're probably going to, when new packages come, they're going to overwrite things. But you can, overwrite things if you were to move this to like etc systemd system. That's a common one that we use for stuff like that. All right. This is one that's good too. You can see if any systems failed as it came up. Were any services affected? Systemctl failed, like that. Promtail service failed. Why did it fail? Long story, but we got to fix it eventually. Or you used to be able to do state equals failed. List units, yeah. And it'll give you the same thing. So -- failed is just a shorthand, but that's the way I used to do it until somebody showed me that you could do -- failed and it'll do the same thing. But yeah, this service failed to come up because somebody deleted stuff. So, all right. Give me 1 second real quick. Oh, man. Had to sneeze there. Sorry, guys. All right, and then there's kernel command options to see how the system booted, dmessage to see how the system came up, if there were errors, if there were things that didn't load, if there was hardware that wasn't connected properly, that kind of stuff, you would see it there. All right, there's our observability summary that you can kind of play with, and some of the same stuff from the other stuff earlier. All right, excuse me. I'm going to stop here for tonight, but we'll keep working on this stuff during the week. If this stuff's interesting to you or useful, like if you like watching this stuff, we do have a Discord. We do have all kinds of useful things going on in the Discord. We're very close to, probably not there yet, but we're very close to 4,000 people. Let me go check. User count. We're 4 away. We'll get there one of these days soon, but we're 4 away from 4,000. So you guys are welcome to hang out down there. We'll be meeting a little bit this Saturday. I do have a party to attend, but I'll be around. Sorry, I just squeezed a water bottle on stream. I know I'm not supposed to do that. But we have all kinds of things for you guys to do down there. Years and years worth of people talking about systems and stuff like that. So you guys are welcome on there. Where on the Discord is the course? Are you currently partway through? Yeah, we are in Unit 11 of 16 right now. It'll be Unit 11 this weekend. If anybody wants to go check that out, you go either to beginner start here and start watching the courses, or you hop right down into, I want to say it's ProLUG. It's right here, ProLUG projects. You guys won't see all this other stuff that I see, but here's all the ProLUG here's all the old projects here. But what's better than going to these is the guys have put together a really awesome book. If you guys haven't seen this book's free, but this is the book right here for the Linux admin course, right there, and right there. And then the security engineering course, which is almost all done, is right here. So here's all the security engineering course stuff. So anybody that wants that, that's right there as well. And the guys have done a really good job putting that together. If you want to get involved with working on that book, they do that on Sundays. They actually write that, and that's all generated. They write it in GitHub, and then it gets pulled out and written into this book format. And you can actually go and you could take the book if you wanted to. You could just go right here to like the top, and you can say I want to print it, and it'll go into a giant print format of like 300 something pages, and you can just print it as a PDF to your own machine if you want to. Save it as a PDF, print it to your machine, and run off like a cartoon villain. I wouldn't care, right? It has all the stuff in there for you guys to get through the 16 weeks of the course. But yeah, we are at week 11 this week, and then we're almost done. So the course is almost done. The security engineering course is done, and I've kind of soft committed to start them up in September again. So we'll probably start them up. There is a nice little certificate that goes with them that Treasure built out, and there's also a validation for that certificate for people that want to use that for, you know, getting into the industry or something. It's just another thing to put on your resume, another positive differentiator for you guys versus everybody else. So, all right. Yeah. I probably shouldn't use the dev null that other way. I probably should just take the out file dev null off of there. Yeah. But either way, it was still doing something. It was still wasting a lot of CPU cycles. That was all I wanted to show, was it was wasting CPU cycles. I have another one that I use. Actually, I can show you guys right here in the baseline. So if you guys are looking for it, hold on. It would be in 12 on the worksheet, I think. Let's go see. The way I make you guys do it in, oh, not there. And is it down here? We use stress as well, but if you want to do it manually, I show, that's just writing, so you can read and write files. But oh, this is the way this is the way to test the processor right here too. You can just melt a processor right here. Tell it to just add the numbers real quick. Right? So it's just gonna add the numbers up to 1,000,000. And that's just gonna loop real quick and do that. Now, that didn't take too long, but the trick is, if you want it to take longer, just make it one order of magnitude larger and see what happens. So, also, the wife gave me some Mambas. I don't know if you guys have ever seen Mambas. They're kind of like little Starburst. What are those things called? Like Starburst? Yeah. And they're basically taffy. If you guys didn't know, those are all taffy candies. Look at these little guys. Very tasty. All right. See how this was all user calls? No real system calls had to be used for this. This is just me and my bash shell right here doing that. But if I made this go do something at the system level, then it would take system time as well, and then we would have a split of time versus the real time. This is what we call wall clock time a lot in high performance compute systems. And you know, if you're ever working with, you'll hear this called wall clock time or real time. And then this is user and system space. Okay. Guys, my wife is back. I got to get out of here, but she got back and she gave me some of these Mambas back. So we'll go to my little end of stream. You guys are welcome to kind of keep hanging out, and I advise people get involved. Like, even if it's not our group, get involved somewhere. Find somebody that's doing interesting stuff that is kind of aligning with your goal of getting into the industry, and go with them, right? Like, if it's us, it's us. If it's somewhere else, it's there. But try to find stuff that's useful and good. On the Twitch side, we'll go raid somebody. We'll go find somebody to raid. Let's see who's on. We're going to go raid to Midnight Simon. He's vibe coding with Claude, so we'll go do that. And for the rest of you guys, I will see you guys later on this week. Take care. Hold on. We're almost done.